I would like to speak of oxido-reduction mechanism and the implication on wine aroma of special wines. I wanted first to indicate that there is among special wine large diversity of evolution with oxidation levels that can be very strong with Madeira wine, sherries, some ports, some tawny ports, and other wines for which there is less demand for oxygen. It can be producible at the origin of banalization of aroma for sweet wines, for example, particularly noble sweet wine, and also sparkling wines, main sparkling wine. At the origin of this oxidative evolution, so in wines where there is no sulfite addition, there is first evidently oxygen that leads to an increased production of acetaldehyde, but also with Strecker mechanism to a strong production of Strecker aldehyde. So we were mentioning phenylacetaldehyde and methionine, for which concentration can depend on to the initial amino acid component, but also there is a strong presence of 2-methylpropanal, 3-methylbutanal, as this was shown recently by Marc and Chiberlet, particularly in Pedro Jimenez wine, but also in cherries with Fino and Oloroso. It was also shown by a work from Roreiro that in Ruby, which are with a more oxidative fortified wine evolution, there is, these components are more abundant, as some carbonide, aliphatic aldehyde, and also diacetyl glyoxal and methyl glyoxide. What is the origin of these components? So Strecker aldehyde that can be formed by the Strecker reaction in the presence of quinonic compounds formed by the oxidation of phenolic compounds, or the presence of decarbonides present in the wine, but also from the corresponding alcohol, for example, methional corresponding issued from methanol, with the presence of hydroxy radical due to the oxidation of phenol, as it was summarized by Ugliano. I wanted to speak of a particular oxidative marker with very strong characteristic odor of nut, curry, and celery, which is sotalone. Sotalone, it is a particular furanone for which the level of abundance it can be very abundant, much over its olfactory detection threshold in lots of fortified wines, particularly in Banyuls, that it was shown by Kuzak et al. And here you see that the fortified one, which was kept with a limited contact with oxygen, the concentration of sotalone were diminished. So this compound is very present in sotalone in Fenifrac. Also, depending on the sotalone, on the enantiomeric form, there are differences in the olfactory detection threshold, which was shown by Ponce. I wanted to show you the relation between the sotalone content and Madeira wines, tawny port wine, in relation with their oxidative aging. Sotalone originates from lots of mechanisms, and recently it was shown that by Pereira et al. During EVAS that amino acid and fructose at 70 degrees centigrade can contribute to the formation of sotalone, and we know that Madeira wines are warm for some of them from Estumagen process, but also it was interpreted that sotalone it can be mainly formed in the presence of acetaldehyde with an ketobutyric acid, ketobutyric acid, through an aldol condensation reaction mechanism. So ketobutyric acid originating from alcoholic fermentation, also formed during oxidative aging. Acetaldehyde evidently related with oxidation of ethanol. And so these two components with an aldol condensation reaction can form the very odorant sotalone. I wanted then to speak of these oxidative markers in other special wines, and particularly I wanted to mention that sotalone, which had been